Alright, so today we're going to talk about 5.3 in our geometry book, which is angles associated with parallel lines. As I've been saying, this goes pretty much hand in hand with 5.2. Here we'll have that we do have the parallel lines, and we'll be talking about the angle relationships with it instead of the other way around. So, just like in 5.2, lots of ideas in this section. One of them is, through a point not on a line, there's exactly one parallel to the given line. So what this is saying, if we have a parallel line and a point, there's only one line that's going to be parallel to the original line through that point, and one line only. So that's really all it's saying. Other idea in this section, if two parallel lines are cut by transversal, then any pair of the angles formed are either congruent or supplementary, and we have talked about these. Those were, the alternate interior angles, alternate exterior angles, corresponding angles are all congruent, and same side interior, same side exterior are supplementary. And the way we can use these in our proofs are, for the congruent ones, parallel lines imply, we could say alternate interior or whatever else we need, or same side interior are supplementary. So pretty similar to the way that we worded it for 5.2, except parallel lines is on the other side. And then two more ideas. In a plane, if a line is perpendicular to one of two parallel lines, it is perpendicular to the other. And this goes hand in hand with the idea that we saw in 5.2, that if two lines are each perpendicular to a third, then they are parallel to each other. So all this one is saying is that if we have a line perpendicular to one of two parallel lines, well, it's also going to be perpendicular to that other one. And another idea that we see is if two lines are parallel to a third line, then they are parallel to each other. So I have, one line here, another line here, and another line. If I knew that, say, A was parallel to B, and A was parallel to C, B and C are both parallel to A, so they are also going to be parallel to each other, so realistically we just have three lines that are parallel to each other. Now I want to just go through a couple examples with you guys. So we see that given line M is parallel to line N, and I see, well, with these two angles, those are both alternate interior. So I know with parallel lines, alternate interior angles are congruent. So let's set those equal to each other. 3x plus 5 equals 2x plus 10. Subtract over our 5. Subtract over 2x. So I have x equals 5. And well, if I want to find angle 1, I also see angle 1 is vertical with that 3x plus 5, so I'll plug in 5. I have 3 times 5 plus 5. 15 plus 5 is 20. So though it doesn't look like it, but remember we cannot assume relative measure, our angle 1 is 20 degrees. Let's look at another one. So here again we are given A is parallel to B, find measure of angle 1. Now I see I'm going to label what my angles are. So I have x plus 3y, let's make that look like a y, 2x plus 30, and 5y plus 20. So now it's time to look at our relationships. We see angle 1 and angle 2 form a linear pair, so they are supplementary, which means we can add them up and equal it to 180. I see that angle 2 and angle 3 are both on the same side of the transversal and both on the interior, so in this case they are also supplementary. Now, I've got x's and y's. That is a good indication that I'm going to have to set up a system of equations, so let's go ahead and do that. So let's simplify these equations and see what we get. So I have 3x plus 3y equals 150. And I have 2x plus 5y equal to 130. Now, well, looks like I've got 3's, 2's, and 5's, so x is going to be a little bit easier to simplify, but not by much. But we can also, if you really wanted to, you can divide out your top equation by 3 and kind of simplify it that way. But I'm just going to go ahead and multiply our top one by 2, multiply the bottom one by -3. So, multiply this one by 2. I have 6x plus 6y equals 300. Multiply this one by -3. So I have -6x minus 15y equals -390. Add them up. So I have -5y equals -90. Divide both sides by -5. So y equals 18. Now, let's plug into one of our equations and see what x equals. So, let's plug into, oh, I don't know this equation. So 3x plus 3 times 18 equals 150. 3x plus 54 equals 150. Subtract over our 54 on both sides, so 3x equals 96. So x equals 32. I've got x and y. Now let's plug into 1. So I have x is 32 plus y is 18. So 3 times 18 is 54. So I have 86. So angle 1 is 86 degrees. Now let's get one more. And we're going to prove that there's 180 degrees in a triangle. So we're told that BC is parallel to DE. Now, if I have that, using the transversal AD, I see angle 1 is congruent to angle 4. And using transversal AE, angle 3 is congruent to angle 5, because those are each pairs of alternate interiors. So, let's set something up for ourselves. So, given, we have angle 1 plus angle 2 plus angle 3 is already 180. And we can say that because BAC is a straight angle, and we know that angles that form a straight angle, if there's 2 of them, they're supplementary, but if there's 3 of them, we just say they add up to 180. We can say that angle 1 is congruent to angle 4 because they are alternate interior angles. So we have, if parallel lines, then alternate interior angles congruent. Or you can say parallel lines imply alternate interior angles congruent. Similar idea. I have that angle 3 is congruent to angle 5. A reason, same as 2. And lastly, through substitution, I will say angle 4 plus angle 2 plus angle 5 equals 180. And I'm done. So this has proven that in every single triangle, there's always going to be 180 degrees. This is something you kind of already knew, but now we have proven it using parallel lines, alternate interior angles, and substitution. So that's all we're going to cover here. We'll work on a couple more examples and then get some homework done in class. See you then.